Hello everyone, and welcome to this latest PV Tech Talk Product Series webinar with major PV inverter manufacturer and ESS solutions provider Sungrow. This is Mark Osborne, the Senior News Editor at PV Tech and your moderator today. Your presenter will be Jeremy Powell. He's the Key Account Manager for Sungrow UK. Jeremy is here to provide some real insight into Sungrow's recently launched DC coupling ESS solutions that offer advanced functionality and benefits to utility scale PV power plants. As usual, please raise your questions on the platform during the presentation. And we also have staff from Sungrow on hand to help. We plan to have around 10 minutes for Q&A at the end. And for now, I will hand over to Jeremy Powell to start his presentation. Thanks, Jeremy.
Hello, and thank you, Mark, and the PV Tech team for the opportunity to showcase Sungrow's DC-DC coupled solution. First, I'll cover off a brief overview of who we are and what issues today's networks face, followed by an overview of the solution, the product components, and a number of typical working scenarios for the system. So, who are Sungrow? We were established in 1997 by Professor Chow. Our focus is solely on renewable technologies. Headquarters, manufacturing, and R&D are in Hefei, China. Our performance is the result of our continuous investment in innovation. For example, with over $90 million invested in 2019. We have one of the largest R&D teams in the industry, with over 1,200 staff, so far amassing over 2,000 patent applications. We continue to invest in technical innovation. While PV inverters are our mainstay, with over 120 gigawatts installed in over 60 regions, we also have presence in other sectors too. For example, energy storage has amassed over 900 applications worldwide. Our floating PV systems has approximately 1/3 of the global market share. Moreover, within China, we have divisions for product development, automotive power electronics, and wind energy converters. So, as our countries rapidly increase deployment of renewable technologies, this can have an adverse effect on the actual grid infrastructure, such as lack of grid capacity. The cost of reinforcement works can be astronomical and potentially render a project dead from the off. Network quality issues. Managing the grid with large amounts of aggregated microgeneration can also present challenges, such as frequency and voltage fluctuation. Then there's the subsidy-free situation. What to do once feed-in tariffs or renewable subsidies drop or are withdrawn? How do we navigate the next revenue opportunities? On the graph, we see periods where the system is in standby, potentially due to negative energy prices on the network. We're all now seeing the benefits of battery storage has to offer the network operators and maintainers. We'll cover some of those benefits in a couple of slides' time. So, typical applications. Here we have some of the main areas we see DC coupled solutions working. On the left graphic, we see unpredictable power due to fluctuations of the irradiance. For this, we can look at offering ramp rate control, a way of smoothing the power swing or reducing the impact of power changes with a combination of PV yield and stored energy from the batteries. The center graphic illustrates the power curve with larger DC-AC ratios that are being designed due to the lower cost of modules. This is good in winter, but what happens in summer? The inverter is only able to convert a maximum amount of energy. Surplus energy is lost. Clipping recapture will allow you to store this surplus energy for use either before sunrise or after the sun sets. Likewise, with the graphic on the right, curtailment recapture would be used when the network operator limits export. In non-storage scenarios, this would mean either the PV plant switching off or turned down, both leading to yield losses. Like clipping recapture, the plant would carry on as normal, however, diverting the energy to the batteries rather than reducing its output. again allowing you to export at the later stage when the network conditions are better. So the main grid benefits of a DC coupled system. So again, I'll highlight a couple of the areas here. If we go from left to right, for the utility applications, resource adequacy has potential to work with the DSOs to balance the network locally. Our solution provides this functionality, allowing you to meet the net load profile. For the network, frequency regulation. As we know, renewable generation is asynchronous, and this is difficult to manage. Having storage coupled to the PV plant allows us to export cleanly into the grid by means of exporting a smoother power curve, for example. And the functions in the plant output control section provides clear benefits to both the local and national networks. So to give a brief comparison of the solution, I've highlighted the main key differences of a DC coupled system against an AC coupled system. And again, to summarize, with the DC coupled system, it allows you to increase the DC-AC ratio of the PV system without fear of loss of yield due to clipping. Greater cost savings can be achieved by reducing the number of MV stations required. This also results in greater system efficiency, which in turn leads to project savings on the civils, the labour, the commissioning, and the O&M costs too. So what makes up our DC coupled solution? In the picture on the right hand side, we have the new SG3125HV-MV DC-30 central inverter. This is a turnkey solution with the MV and RMU integrated into the ISO container. I'll cover off the inverter features on the next slide. To the left of the inverter is the SD1250HV DC-DC converter. This is scalable. You can add up to 3 DC-DC converters per -30 central inverter station. These DC-DC converters work with 1C, 0.5C or 0.25C battery ratings. Another feature to note is that you can install the PV inverter first, and should the business case or the grid requirements change, you can install the DC-DC converters and batteries at a later stage, as the connectivity is already built into the -30 inverter. The SG3125HV-30 is a 1500 volt central inverter. It has 2 MPPTs, allowing up to a maximum of 28 DC inputs. It also has the DC-DC connectivity within, as I mentioned previously. The inverter itself has a small form factor, just 2.2 meters wide, 2.2 meters high, and 1.6 meters deep, compared to the previous -20 version, which didn't have the DC-DC connectivity. It was housed in a 20-foot ISO container. As you can see, it can support and perform multiple grid functions, has high efficiency rating due to the advanced 3-level technology, plus it has integrated zone monitoring functions for online analysis and troubleshooting. With the system cooling design, we can operate in temperatures up to 50 degrees Celsius and not experience any lossing or derating. One of the highest in the market, allowing us to install the inverter in the most challenging of environments. So the DC-DC converter, our SD1250HV DC-DC converter, is a modular system comprising of the outer housing, which you can see on the bottom left of the screen, and 10 SD125HV bidirectional boosters, as seen on the top left of the screen. It has again a small form factor, being 2.2 meters wide, 2.2 meters high, and 0.8 meters deep. The boosters are situated in the left and right hand sections of the SD1250HV cabinet. You have 5 on the left and 5 on the right hand side. Each unit has an independent DC isolator on the front of each booster. The center cabinet allows for easy access to the DC connectors from the batteries and the connector from the inverter itself as well. Making installation and configuration simple and easy. Here we have the first of our scenarios. This would be considered a standard working mode. So this is PV export and battery charging. We can see here that we have full irradiance onto the array and it's producing 5 megawatts of yield. The PV inverter is in charge of the MPPT control and the priority is export. So you can see here that it's taking 3.125 megawatts out into the grid. The PV inverter is judging whether there is any extra energy that can be diverted from the PV plant. And as you can see here, the state of charge of the battery is low, so the additional energy is diverted. So as you can see, 1.25 megawatts going into the battery. Scenario 2, we have the PV plant with no PV export, battery charging from the grid. And as you can see from the graphic, it's nighttime. So the PV plant switches are disconnected. Again, this scenario is considered to be a standard working mode. In this situation, the state of charge of the battery is low, power drawn from the grid to recharge the batteries. The battery can charge and discharge throughout the night. Scenario 3 sees the first of the non-standard working modes. So the irradiance in this case is low at 400 watts per meter square, 2 megawatts being produced. State of charge of the battery is low and requires charging. The system prioritizes the recharge of the battery over the export energy to the grid. In this case, we have 1.25 megawatts going into the battery and just 0.75 megawatts going to export to the grid. Another non-standard scenario, during the day, grid zero export. Again, so these are the periods where we get the curtailment. There is only 1 megawatt DC coming from the solar array. State of charge of the battery is low. The battery charges as a priority. The DC-DC converter is taking over the MPPT tracking and charging the battery. When the state of charge of the battery achieves 100%, the controller will send a command and stop the batteries charging, allowing you to store and save the energy in readiness for when the grid becomes available again. And finally, this is a combination of PV export and battery export. Again, considered a non-standard working mode, but this scenario is all about maximizing that grid connection. So during the day, the irradiance is lower than forecasted, so we're looking at a cloudy day, for instance. Energy is available also in the battery. The inverter can call upon the stored energy to support the export. Again, we're seeing now 2 megawatts coming from the PV plant, 1.25 megawatts coming from the battery, and maximizing that grid connection at 3.125. This would benefit situations where you have specific generation or PPA requirements and need to meet energy demands. So to summarize, the SG3125HV-MV DC-30 and the SD1250HV DC-coupled solution is able to bring in enhanced grid support functionality to ease expensive infrastructure upgrades, smooth the flow of energy into the grid by providing ramp rate control, store energy during times of curtailment for use at a later stage, bring savings to the build and its operation by reducing the balance of plant, global reduction on plant costs is making DC-DC solutions more viable. So that's it from me. Thank you once again for your time. I hope you enjoyed the presentation. Should you require more information, I'll be more than happy to provide. I look forward to your questions, and now I'll pass you back to Mark. Thank you.
Well, thank you there, Jeremy, for your presentation. We've had quite a lot of questions come through. Just to remind people, there are Sungrow staff are in the questions area to try and help you and put you in touch with the right people after this presentation. Also a reminder that if questions haven't been answered when we finish here today, the platform stays open so that you can still ask questions, and Sungrow staff will be here to help you for a short time afterwards. So Jeremy, let's start with one question that's come through, and I think it's a few people have asked pretty much similar. We talk about the energy storage side very much, obviously at the utility level. What's the type of scalability to this? Does this go down to, say, you can use this at the 1 megawatt level, or what's the kind of flexibility here?
Thanks, Mark. Yes, so we have a number of different solutions available for storage energy. So for the smaller systems, we would have we do have a range of smaller units that we're able to supply for the smaller systems. Apologies.
Right. Okay. Looking here, several people really just following, I think, about this. Yeah. How does the solar inverter manage the voltages of a PV plant and battery from a MPPT perspective?
Yes, that's a good question. The main magic there is with the local controller. So the local controller is communicating with both the DC-DC converter, and it's also talking to the PV inverter as well. So the control in the local controller will then actually ascertain not only the levels of what is in the stored energy, but also is able to pick up on the yield that's being produced from the PV park. Okay.
Now we've had a lot of these type of questions in the past when people are discussing the choice really between string inverters and central. So can the DC coupling actually work with string inverters instead of central inverters?
Not this current configuration. We do have should we say, we do have a solution for the string inverter systems. My colleagues will be able to give a little bit more clarity on that type of product. But for the large scale, there is something that I believe that our colleagues are working on and are due to bring out later this year. So I don't have too many of the product details at the moment, but it is something that will be coming to market.
Okay. Couple of others that have just come in. What is the DC voltage range on in and output side of the DC-DC converter?
That's a very good question.
Okay. Not sure you can answer that one today. Yeah, we'll get. That's fine. We'll get. I'm sure someone from the Sungrow team can do that. There's another question here. Does the SG3125HV30 include one DC to DC in its cabinet, or is it DC converter in a different cabinet?
Sorry, Mark, could you say again?
Yeah. Does the central inverter include one DC to DC in its cabinet, or is the converter part in a different cabinet?
So the converter part is in a separate cabinet. So you have the SG3125HV-MV-30 has the PV inverter, it has the MV and the RMU in there, and then in a separate unit you have the SD1250HV, which then contains the 10 DC boosters. You also have the functionality with that central inverter to parallel 3 of those DC DC converters as part of the solution, so you can scale it up. Now, with the batteries themselves, it can work with different C ratings of batteries. So the 1C, which is 1 hour, 0.5, which is your 2-hour battery, and we can go down to 0.25C as well with that system. So again, when we're talking about yield capture or curtailment grid curtailment, we're able to store a lot more of the yield into the batteries, because obviously you can it's a longer duration import and export of the batteries.
All right, yeah. Slightly different question. In fact, we didn't cover this in the presentation, so I'm not sure, but I thought it was a good question to throw back at you. Does Sungrow have its own bidding software to interact with grid pricing?
No, is probably the better answer to say. We do have a, so it depends on the regions.
Yeah.
Obviously, if we take the UK, for instance, you would have your aggregators that would be carrying out that service. Now, our systems would integrate with those aggregating softwares that would then carry out and do the bidding. We do have, again, the local controller itself in other regions. It has the functionality to you can actually sort of execute or send the commands to charge and discharge to that system, and also from a microgrid perspective, so it can actually take control of the overall system and charge and discharge the system under its own intelligence.
Okay. Well, you mentioned the discharge side. I guess there was a question here that can the batteries be discharged during PV generation with the PV curtailed to zero export?
So if there's the zero export, you're saying, to the grid,
yeah,
but can the PV charge and discharge the battery?
Yeah.
Well, it can charge the battery.
Yeah.
If you're discharging, you wouldn't be able to, because the system's curtailed, so zero export, there's nowhere for the energy to go. But for in one of the scenarios that we had, which would be considered to be the non-standard, so you've got zero export, what you can do, if there is PV that is being generated, you can store that directly into the batteries. Got
it. Okay. Another question here that's just come in. In standard conditions, I'm not sure what specifically that is, but in standard conditions, what is the maximum DC-AC ratio of the inverter?
Yeah, that's a very good question. I think it depends, in terms of where the project is, in terms of the irradiance levels in those particular areas as well. We do have some examples that we can follow up and to give them some scenarios, but our engineers are more than happy to provide that advice on a project by project basis. But we have seen, in some cases where we've seen 50% extra in terms of the DC-AC ratio, or even in some cases even higher than that. So it's all about the project itself, the location, and just taking into consideration a little bit more of the project specifics.
Okay, this should be an easy one for you. And again, we didn't really make this explicit, but obviously as a new product, several people have asked about your product availability. Is this available now, this solution?
Yes, it is. There you go.
Yes.
So we do have a number of plants where this is where this has been deployed. The US market is an area that we've deployed DC-DC coupled solutions. Just to give an example.
Yeah, just to let people know, when we actually do these product webinars, we make it quite clear that if it's not available, like in that quarter that we're doing the webinar, you need to explain when it is going to be available. And because we didn't have that slide, just to let people know, we knew that it was already in the market, so people can understand that we tried to be very clear about the availability of any of these products. One here. Is the inverter capable of providing grid frequency regulation while solar PV production is on?
That's a very good question. Yes, it is. And again, it would really be a point to look at a project by project and country specific requirements. Some countries vary, so there is a capability of being able to offer this.
Right. Yeah. And just looking at the time, yeah, we've got a chance just for a few more questions, I think. And we've got a flood of these coming through, so bear with me when I try and pick some ones here that we've not really already answered. What does Sungrow recommend? Sungrow recommend the type of batteries used with the SG3125? Does that make any sense?
The types of batteries, yes. So we have Sungrow's own batteries, and then we do have partnerships. As you know, we have again, if we're looking at a DC-DC coupled solution, then it would be the Sungrow solution on that one. We are able to work with other batteries, but they're really done on a case-by-case basis. So we need to work with the manufacturer in terms of the types of communication protocols that would be required to talk with the battery management systems. You know, we are able to provide the full solution. So batteries, the DC-DC converter, and also the central inverters. So a one-stop shop. Yeah.
Well, that funny enough, that brings on several questions, and again, we didn't spend the time really on this aspect, but from a warranty perspective. The questions are really related to Sungrow covering, the entire system, warrant, storage, inverter, and the, all the other ancillaries. Mm-hmm. The warranties that's part of the service. So I would say that these warranties are completely covered by Sungrow.
Exactly. I mean, we have, we have the warranties for the central inverter itself. We have warranties for the MV systems in the RMU. We also have the warranties for DC and also the battery system itself as well, the actual battery modules. So we have varying levels of warranties, and they're extendable. So as I say, we normally get to those discussions when we're sort of fleshing out one of the projects and going deeper dive into the specifics of the actual projects and the wants and needs from a commercial aspect as well.
Yeah. And I just to follow up, really, just to mention, I know we talked about asked about the batteries, but I mean, you are supplying those batteries.
Correct.
Yeah.
That's right. Yes. We have, as I say, we have the facility in Hefei, where we're able to manufacture and system integrate all of the components, and then it's simply just a case of final assembly in location once the foundations have been laid, and then it's simply just the case of running AC and DC cables to the solutions themselves. So yes, we try and make it so that it's as I say, is that one-stop shop for the components.
Right. Yeah, and I think just let people know, I've actually been to the packaging assembly side of the facility, so I do know that you do that in-house. was there a year or two ago, very impressive facility as well. Highly automated, if everyone wants to realise, very automated technology, manufacturing processes being used. Just a quick final one, looking at the time, and this is difficult because I'm trying to look at see where we've had quite a few questions that maybe could be answered all at once. Here's one here. Can the system together with solar behave as grid forming? I'm not sure what that means. If that's something you're aware of. And things
the grid forming capability.
Yeah.
So I'm going to say no at this point. Sorry, I do apologise for not knowing that level of detail.
Okay, no problem.
But please make a note of the person that asked that, because we'll get back to them with the correct answer.
Yeah, good. Yeah, so that's a good point.
I've just seen one of the questions with regards to asking whether it works purely with lithium-ion batteries, or does it work with flow batteries? This is a lithium-ion battery solution only.
Yeah, great. Well, there's been a flood of questions here today, which is really, really good to see. And we've not got to a lot of these. And I appreciate that this is not one of our sort of hour-long Tech Talk series. It is really about introducing and making people aware of what this system can actually do. And there is a lot of things that it can do. So I'm not surprised we've had a lot of questions today from people. But once again, Jeremy, thank you very much for your time today. And also, just to remind people, there are staff from Sungrow here that are trying to get through and answer questions for you and get in contact with you. So stay with it. Although we're ending the webinar now, the actual platform will remain open. So, and Sungrow people are going to try and get to most of the questions that still yet to be answered. But once again, Jeremy, thank you today, and thank you for so many people joining us today. It's been really, really good, and the questions have been just overwhelmingly good. So once again, thank you very much, and hope to see you soon. We're now finishing the webinar. Thank you.
Thank you, Mark. Thank you, everybody.